All right, we're going to take a look at example 3 in the curve sketching notes, and notice that I immediately wrote it like this. I also want to make a comment that remember that when you have this odd power, I'm going to say this is a vertical tangent alert, that when we had a cubic or cube root, that there was a point of inflection that had a vertical tangent line. So it's going to be a high possibility, if you think about how the derivative is going to come about, that this is going to have a fraction with a negative exponent and end up having a place on the derivative where it's not defined. However, thinking about what we know from pre-calculus, why is this going to be a vertical tangent alert, is because we have m squared minus 4, which is a continuous function, inside of a cube root, which is a continuous function. So we have the composition of continuous functions times a continuous function. So we have these combinations of continuous functions, which means that g is going to be a continuous function because it's the composition and product of continuous functions. So we know that our domain is going to be negative infinity to infinity, and so that's going to essentially be something that we need to worry about, that we're going to have to worry about, that it's not differentiable though, because we'll see that when we take the derivative, the minute that I have this power of 1/3, using product rule with chain rule and all that stuff, this is going to be a negative 2/3, and you're going to end up with a fraction in your derivative. Now, in terms of your end behavior, taking a look at this, you've got the product of m and m to the 2/3 here is kind of the dominating term. So that would be m to the 5/3, which is all odd, which is probably going to be the limit, if I had to guess, as x goes to infinity of g of m, based on the dominating term, that on the right side is going to go to infinity, but on the left side, the limit as, I guess instead of x right there, I should be paying attention and saying m. As m goes to negative infinity of g of m, that would be negative infinity. So you can kind of think about, where's this going to go to negative infinity? This is going to go to a positive, which is cube root of a positive is positive, but then times negative goes to negative infinity. So survival of the dominant term, I'm looking at the m to the 2/3 times m, which is m to the 5/3, and thinking about where that is going to go, okay? Kind of give you some ideas. And again, we'll come back in later with that and see what L'Hopital did for us. It's in the next section to do a better way of looking at that. But then we also kind of looking at this is already nicely factored. So I actually do know what my x-intercepts are. So I'm going to go ahead and talk about x-intercepts, or quote unquote m-intercepts, are going to be at m equal to 0 and m equal to plus or minus 2. So we know 0, 0, 2, 0, and negative 2, 0 are going to be points on this graph because it factored nicely, so I went ahead and did that. In terms of symmetry, plugging this in, if you plug in negative m, this stays the same, but you're multiplying it times negative m. It's going to be opposite of what you have. So I'm going to say that g of m is odd, has odd symmetry, because g of negative m is going to equal the opposite of g of m. So I kind of think about that in my head as well, okay? So we get that going. We've done some pre-calculus. Now we're going to bust out the calculus. We're going to take the derivative. Now we have to be careful. Our derivative is going to require use of product rule and chain rule. So our derivative is going to be our second times derivative of the first plus our first times derivative of the second, 1/3 m squared minus 4 to the negative 2/3, don't forget chain rule, times the derivative of the inside. And then because we're going to want to use this, we are going to need to simplify. So we're going to utilize the factor out the GCM, which is going to be our m squared minus 4 to the negative 2/3. Remember, you take out the highest power. We subtract 1/3 minus negative 2/3 would give me m squared minus 4 plus this we took out. We're left with what, 2m squared over 3 inside right there. All right, so then we combine like terms, turn this into a fraction. Let's see, m squared plus 2m squared over 3 would be 3 plus 5. So that on the top would be 5/3 m squared, just combining like terms, minus 4. We're going to move that to the bottom, m squared minus 4 to the 2/3. And if you want to, you can write it as that over cube root of m squared minus 4 squared. It doesn't really matter in that. Our critical values, our derivative, g prime of m, is going to be equal to 0 when the top equals 0. So that's going to give us, you know, have to do a little algebra on this, add 4, so 5/3 m squared equals 4. M squared multiplied by 3/5 would be 12/5. So we're going to end up with m equals plus or minus the square root of 12/5. Okay. We also need to do in this one g prime equal to does not exist, because even though our derivative, we have a fraction of the derivative, we were continuous and defined everywhere. So we're looking at a place where we have possible vertical tangent lines. That's where this is coming in. G prime does not exist when the denominator equals 0. So that's for m equal to plus or minus 2. So all of these are critical values, and you do need to put them onto your sign chart. So we have our g prime and our g. So we have our plus or minus 2. Let's see. That's just 0, just marking that. Let's do negative 2 and 2. Now our square root of 12/5, I would just go and get that from the calculator, just so we know approximately where those values are. And it's about negative 1.55. So we'll just stick it right here. Negative square root of 12/5 and our square root of 12/5. And then just because I don't want to confuse myself, let me take that 0 out just so that it's not something that I'm looking at. All right, and then we have to go and we have to figure out our sign chart for this. So for our first derivative, and you know, just plug and chug, you know, the top part right here, pick a like negative 10 is going to be positive. Negative 10 here is going to be positive. Positive over positive is positive. Then we had our 0, we had our undefined here, undefined there, and 0 there. Picking a value in between here, you know, and this is where we might just pick the calculator out and take a look at it, but it's going to end up being plus here. I'll leave that for you, minus in here, and then plus and plus. So what that tells me about my g is that it increases, decreases, increases, and increases. So our only maxes and mins are going to occur at these two critical values right here, not at negative 2 and 2. So g has a relative max at x equal to negative square root of 12 over 5, because g prime switched plus 2 minus. And g has a relative min at x equal to positive square root of 12 over 5, because g prime switched minus 2 plus. And then it doesn't have either a min or a max at negative 2 and 2. Right? We do need the coordinates of that. And so we have our negative square root of 12 over 5. And just plugging that in, just so you guys, this is approximately negative 1.55. And if you plug that in, you get about 1.8. And then this one would be square root of 12 over 5, which is approximately 1.55. Plugging it in, you would get negative 1.8, just so we have those because it asks for the coordinates. All right, and you're like, okay, now we got to move on and we have to find the second derivative. So what I'd like you to do is try to simplify your first derivative, figure out your first derivative, what form you want to use to get your second derivative. So I'm going to pause for a second, let you think about that. So I'm going to find the second derivative using this form because I'm okay with quotient rule, chain rule. So we would do our low d high, which is going to give me 10/3 m minus your high, 5/3 m squared minus 4. Low d high minus high d low, so times 2/3 m squared minus 4 to the negative, subtract 3/3, negative 1/3 times derivative in the inside times m, remember your chain rule, all over your low squared, so we'll do that to the 4/3, right? And then we need to simplify, so we're still going to GCF, pull out a common factor. I'm going to pull out a 2/3, I'm going to pull out an m, and I'm going to pull out an m squared minus 4 to the negative 1/3, okay? If we pulled 2/3 m out from this, we would be left with a 5. 2/3 minus negative 1/3 is going to leave me m squared minus 4 minus, be careful with that. We pulled out a 2/3, we pulled out an m, we're going to be left with this 2, so bring that. And I pulled out this m squared minus 4 to the negative 1/3 out. So we're going to have our 5/3 m squared minus 4 left. Close your parentheses. All over m squared minus 4 to the 4/3. We see how this is really just going to be a great big algebra problem. All right, just giving myself a little bit more room here. All right, and then we're going to simplify, combine these two together, bring this down, add it to that. It's going to give me on the bottom m squared minus 4 to the 5/3. This 2/3, if you want to, we can do a 2 and a 3 here, times. And then we're going to simplify on the inside of that. And if we simplify on the inside, our second derivative ends up being 5m squared minus 10/3 m squared, which is going to give me, so I combine like terms, 5m squared minus 10/3 m squared is 5/3 m squared. And I had minus 20 plus 8, which gave me minus 12. So we find our possible points of inflection. G double prime equals 0 when the top equals 0. So 5/3 m squared equals 12. M equals multiplied by 3/5. So 3 times 12, 36 fifths, and then square root plus or minus, which is going to be plus or minus 6 over the square root of 5. And then G double prime does not exist for m equal to plus or minus 2. We'll do our sign chart. So we go ahead, set that up. Okay, so you guys can pause this. I'm trying to save time, so I only have 15 minutes for the video. That I basically found my signs, talk about my concavity, and you'll see that it switches each time. So we have points of inflection at plus or minus 6 over square root of 5, plus or minus 2, and 0 because we switch signs. Now, if we go to the graph, here are all of those points plotted. Now, what you have to remember is kind of what we're doing is it was increasing. Here's the max, here's the min, so it must be increasing, decreasing, increasing. And as we are sketching, we have to watch our concavity. It should be down and then up oops, try to get through this point right here, and then down